Hi, are you a student in geometry who feels that you've been duped by Mr. Peacock? You've been told this is geometry, and yet where are the shapes? Hi, I'm Bill Williamson of Billy Willie and Mark Attorneys at Law, and I'm filing a class action lawsuit saying if this is going to be called geometry, there should be shapes. But don't take my word for it, listen to these.
As an elementary teacher, I can tell you geometry is when you study shapes. We just finished that unit last week in 3rd grade.
When I found out this year I was going to do geometry, I was ecstatic. I love shapes, triangles, the four-sided ones, all of them. But so far this year, it's just been like proofs. And I mean, I don't even think the teachers know the difference between transitive and substitution.
That's right, but don't just take their words for it. I have right here a textbook, a geometry textbook, and if I open up to any page, what am I going to find? Oh, that's right, shapes. And yet the only shape we've had in this class is that annoying triangle from the last unit. Now, if this next unit has shapes, I'll drop the lawsuit. But only if, what's that? Our next unit is triangles? Okay, this is geometry.
All right, so let's talk about triangles. Triangles have exactly 3 sides. The sum of the measures of the 3 angles is 180 degrees. This leads us to the third angle theorem. If 2 angles and 2 triangles are congruent, then the third angle has to be congruent as well. For instance, if we had a 60 and a 70, then we would have to have a 50 as our third angle. Triangles can be classified by either angle or side measures. So let's start by classifying by angles. First, we have the acute triangle. And what an adorable little triangle that is. That's right. An angle in a triangle, all angles in an acute triangle measure less than 90 degrees because all the angles are acute. Now, if one of the angles does not measure less than, and in fact measures exactly 90 degrees, we have what's called a right triangle, where there is exactly one right angle. Now, the 2 other angles in a right triangle are going to end up being complementary, or add up to 100, or add up to 90, which makes sense because 180 minus 90 leaves only 90 degrees left for the other 2 angles. Finally, if it's neither acute nor right, the third angle would have to be obtuse, which would make an obtuse triangle. Obtuse triangles have exactly one obtuse angle. The other 2 angles are in fact acute. Now there is one very special type of acute triangle, and that is equiangular. And an equiangular triangle is an acute triangle where all 3 angles measure exactly 60 degrees. This is also known as an equilateral triangle, as all 3 sides are going to be congruent, but we wouldn't classify it if we're classifying by angles, because that would be classifying it by sides. So let's talk about what happens when none of the sides are congruent. That's called a scalene triangle, so none of the sides are going to be the same length. Next, what if 2 of our sides are equal? We call that an isosceles triangle. Now you might notice that whenever I write this next sentence, it's not going to just say 2. It's going to say at least 2 sides are congruent. That means that yes, if all 3 sides are congruent, it is still considered isosceles. Now, the congruent sides are actually what we call legs, whereas the third side is called the base. Now, next thing that we need to know here is that the angles opposite the legs, so like this one and this one, so these 2 angles are called base angles, whereas the angle opposite the base is called the vertex. Now, our last type of triangle here is a special type of isosceles triangle called an equilateral triangle. All 3 sides of the equilateral triangle are congruent, and because all 3 sides are congruent, the 3 angles are going to be congruent as well, which is why it is also equiangular. All right, so what we're going to do now is we are going to classify our figure by angles. So our first one here is triangle DBC. So we're talking about this triangle right here, meaning all of this stuff doesn't matter. This is all gone now. So when I look at this right here, DBC. Well, the angles are 70, 20, and 90. So since one of the angles is 90, this would be a right triangle. Ooh, that looked bad. I'm just going to write the word triangle. All right, so now we have angle ADC. So in that case, we're actually talking about this big angle right here. So the only angle that we need to actually figure out is this one. So 31 plus 70 is going to be 101, which is greater than 90, which means this would be an obtuse triangle. All right. So now let's classify this next one by angles, or by sides actually. So we're talking about EGH. So that is this big triangle. Now notice EH and GH are both 8. They aren't 7.4, that's this middle line. So if these are both 8, then this is at the very least isosceles, but let's double check about the length of the bottom. So this is 3 and this is 3. 3 plus 3 is 6. So 8, 8, 6, which means 2 of the sides are congruent. So I would call that isosceles. Now let's talk about our next one. This is EFH. So this triangle right here. Well, we've already established this is 3, this is 8, but this is 7.4, meaning all of our lines are different, so this would be scaling. All right. So in this case, we are trying to find the length of the sides. Now, in this case, this is an equilateral triangle, which means all 3 sides are congruent. So if I want to find the length of the sides, 6y is going to be the same as 4y plus 12. So we'd write this as 6y equals 4y plus 12. I would subtract 4y. 2y equals, oh, that's a 12. Equals 12, divide by 2, y equals 6. But now that's not what I need. I need to figure out the length, so I plug it back in. 6 times 6 is 36. And just to confirm, 4 times 6 plus 12 is 24 plus 12, which is also 36. So yep, they are the same. All right, so now we're going to very quickly talk about the exterior angle theorem. So the exterior angle theorem is basically this. So we've already established that angle 1, sorry, I should be writing the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 180 degrees. We've already established that. But here's the thing. We also know that the measure of angle 4 plus the measure of angle 3 equals 180, and that is because these are a linear pair. So now that we've established both of those, the thing is I can substitute these two have to be equal to each other in this case. So I'm going to say the measure of angle 1 plus the measure of angle 2. These, by the way, are called remote interior angles, is going to be equal to the measure of angle 4, which is the, you know what, I'm going to actually write that in a different color. Measure of angle 4, which is the exterior angle. So there we go. the sum of the measures of the two remote interior angles is equal to the measure of the exterior angle. So let's try that out. So in this case, these two angles are going to be equal to our exterior angle. So 3y plus 1 plus 2y plus 2 is equal to 48. At which point my first step is combining like terms. 5y plus 3 equals 48. And then let's go in minus 3. Minus 3, 5y equals 45. That means y is going to equal 9. Then I just do 3 times 9 plus 1. So that is 27 plus 1, or 28 degrees. And just to confirm it, 2 times 9 plus 2, that's 18 plus 2, that is 20. So yep, it is 28 degrees. All right. So now that we've done that, let's talk a little bit about triangle congruence. So triangles are congruent. Well, any figure is congruent with certain things. They have to have the same size and shape. So corresponding angles and corresponding sides are in the same positions with in polygons with equal numbers of sides. So you will hear me use the phrase the corresponding angle or the corresponding side. So two polygons are congruent if and only if their corresponding angles and sides are congruent. Thus, triangles that are the same size and shape are in fact congruent. So let's look at these. Here are two triangles, and I'm going to mark them up. All right. So in this case, what we want to do is we want to name each of these triangles. So I'm going to start out by just naming the red triangle A, B, C. Now we are going to say that that is congruent to our blue triangle. But to name the blue triangle, we first have to make sure that we have the right angles combined. So I look at A. A has one arc mark. So then I go over, and D has one arc mark. So I go D. Then I write a better D. It's not like that's the first letter of my name or anything. And then I had B as my second letter. So I go to B. That has two arc marks. That's E. So I write E. And then, well, the third line is going to be F. Now, just to confirm, AB and DE should be the same length. So AB had 3 hash marks and DE had 3 hash marks, meaning they are congruent. BC and EF, 2 and 2, and then 1 and 1 for our third side. So that worked. Let's try this one. I'm once again going to name it triangle ABC. But then let's look at what this one is. So A has two arc marks. So then I look, L does not, but M does. So I'd be saying is congruent to M. Then B has one arc mark, which is the same as L. So L, and then N would be our third one, which because they both have 3. Just to confirm, let's see, 2 to 1, AB is the 1 hash mark. ML is also the 1 hash mark. So yes, everything is working out just right on there. All right, so now let's talk about what we would do in this case. So we are wanting to find the measure, we want to figure out what S is right here. So in this case, I already know that this angle is 66 and that this angle right here is 55 because they are congruent. So what I know in this case is all 3 angles add up to be 180. So I would say 2S plus 10 plus 58 plus 66 equals 180 degrees. Then from there, I'm just going to do some basic math. First, I'm going to combine some like terms. 2S plus, let's see, 58 plus 66 is going to be 124 plus 10 should be, if I'm correct here, 134 equals 180. Then I just subtract 134. 2s is going to equal 46, which means s is going to be 23. Just to confirm it, let's see. This should end up being 100. This should be 56 if I put it in together, and sure enough, that's what it is. So there we go. And that's how we would solve this problem using triangle congruence. And with that, my only request is that you please like and subscribe, hit that bell for notifications, and all of that jazz. Have a wonderful day. Goodbye.